We can also use these concepts backwards and graph a line using the knowledge about their slopes. So in this example, we are supposed to graph a line that's parallel to the given line and that goes through the point that we have provided. Well, in order to do that, we need to figure out what slope our line has, the line that we have in front of us here. And let's go ahead and do that then. I'm going to pick these 2 points and I'm going to figure out what the slope is of that line. From the point on the left, I need to go 1 step down, so that means -1, and I go 2 steps to the right. -1/2, or in other words, -1/2 is our slope. Now, this is exactly the thing I'm now going to do from the given point that's all there by itself, all lonely, right? And we're going to go 1 step down from this point and 2 steps to the right, and that will give us a second point. And as you know from lots of experience in Algebra 1, 2 points is all we need to draw a line, and this line is parallel to the given line. Okay, very good. And of course we can do the same thing with lines that are perpendicular as well, right? Now we're going to graph a line that's perpendicular to the given line, and it also supposed to go through the point that we have provided. And again, let's start by finding the slope of our line that we have here. And I'm going to use these 2 points to determine our slope. I'm going to have to go up 4. So that's a +4. And I'm going 1 to the right. Slope is 4/1. And now we're supposed to find the slope of a line that's perpendicular. Let's remember what that really means. The slope has to be the opposite reciprocal. Right? Opposite reciprocal. It's not as easy as it was for the parallel lines. So the slope of the line that we're now looking for has to be negative, since this one is positive, and we are flipping our fraction, -1/4. Well then, let's find a second point so we can go ahead and graph our line, starting with our point here. Negative means I'm going down 1, and I'm going 4 to the right, and I land on a point that we have already found before. And here goes our perpendicular line. These 2 lines are perpendicular that we graphed right now using the knowledge about their slopes. Okay, very good, you guys. Let's move on to slope-intercept form. Slope-intercept form. Again, we have known this for a long time. The slope-intercept form of an equation is y is equal to mx plus b. Slope-intercept form, that's what it's called, and it's called because right in our equation we have 2 pieces of information. We have the slope, because m is the slope. And we also have b, and b is our y-intercept. In other words, this slope-intercept form gives us a point, and it gives us the means to find the second point using the slope, and with 2 points we graph our line. That's what we have done all year through Algebra 1, and we can keep doing that in here. Yay! Let's look at some examples. Find the slope of each line, then tell if the lines are parallel, perpendicular, or neither. In our first example, the lines are nicely in slope-intercept form, so we just go ahead and pick the coefficient of our x term to find our slopes. The slopes of the first line is 4. The slope of the second line is negative 1 over 4. One is positive, one is negative. They are reciprocals, but we can also go ahead and do the math. 4 times negative 1 over 4 is equal to negative 1. These two lines are definitely perpendicular. Let's look at our next example, and here we see that the lines are actually not in slope-intercept form. They are in, you remember, standard form. And so the easiest way for us to do would be to just convert them back into slope-intercept form at this point, because we have the formula for slope-intercept form right here. There are two easy steps to perform when we want to do that. First, we need to move the x term to the other side. And then we divide everything by the coefficient of the y. And when I say everything, I mean both terms on the right. So our answer, our rewritten equation here is y is equal to positive 3 over 2x minus 3 halves. And we're going to do the exact same thing for the other equation. First, we're going to subtract 3x from both sides. We get negative 2y is equal to negative 3x minus 8. Divide everything by the coefficient of y, negative 2. And some people like to write it differently. Write it out like that. That's perfectly fine as well. Make sure either way that you always divide every term by the negative 2. You get y is equal to 3 halves x plus 4. And now let's look at their slopes. This line has a slope of 3 halves. This line has a slope of 3 halves. M1 is equal to M2. These two lines are parallel. Okay, looks good. I'm going now to number 10. X is equal to 5, x is equal to negative 1. Well, that doesn't look like slope-intercept form to me. But what we do remember is when we have only an x, this is Vux. Both lines are Vux. What does Vux mean again? They are vertical lines, they have an undefined slope, and that's because we only see the x in the equation. They're both vertical lines. The slopes are undefined, so we cannot do any math with the slopes. But do we have to? They both have the same slope, both times undefined, right? Two lines are both vertical with an undefined slope. These lines are parallel. And number 11, well, it's a little bit like it, but still different, right? We got one line that has an x in it, and only an x. Well, that one has to be Vux. That one has to be a vertical line. And we have another line that has a y in it, and only a y. This is hoi, and this is a horizontal line. Now let's think this through a little bit. A vertical line goes like this, and a horizontal line goes like this. Almost looks like a coordinate plane, doesn't it? And we know that in the coordinate plane too, the two axes have an angle, a right angle of 90 degrees. They cross each other at a right angle. Let's just write down, because we have the information, the slope of the first line is 0 because it's a horizontal one, and the slope of the second line is undefined. And even though we can't do any math with it, just looking at the picture, we can say that these two lines are perpendicular. Very good, guys. Now let's move on to some constructions. We have talked so much about parallel lines that we can now go ahead and construct a line that is parallel to a given line and that goes through a point which is not on the given line. So I realize that you will not be able to do this construction with me at home if you don't have a compass at home. That's fine. Just watch the steps and also make sure that you read the instructions to be ready to do the practice when we get back to class. All right, we start off with a given line K and a given point P. And now the first thing we need to do is we draw a random line, an arbitrary line that goes through the point P and intersects with our line K somewhere. It can be anywhere we want, okay? Now I'm going to make sure that my intersection point is to the left. And just moving my ruler around a little bit, we should also eventually get there. So that is most likely way easy at home. Here we have a good position, and I'm going to draw a line that goes through point P and through our first and original line. I'm going to give this new point where these two lines intersect a name, just to make it easier. This is point Q. Now I'm going to take my compass and put the center of my compass on point Q, and I'm going to draw an arc that crosses both lines. An arc that crosses both lines, and now without changing the width of my compass, I'm going to move that compass to point P and also draw an arc at point P, which has a similar size. Okay, so see that you have the arc that you drew from point Q has to cross both lines. The one from point P doesn't have to cross the bottom line, but it has to definitely go further down than point P itself. So what we did when we drew that first line there ourselves, we created an angle. And this angle, essentially with the steps that we have now performed and are going to continue to perform, we're going to copy that angle. And you have already copied angles. So let's do this. We're going to now move our compass to that point of intersection between the arc and our self-created line, and we're going to measure how far the distance is between these two points, these two intersection points. And in order to see that we have measured that right, we're going to draw a little arc here, and that should go through our intersection point. And now we're going to move our compass to the other intersection point. Needed to flip my compass around here for a second. I'm going to put the center of my compass to the other intersection point between the line and our second arc. And without having changed the width of my compass, I'm drawing a second arc to create another intersection point. I'm going to give that intersection point a name. I'm going to call it R. And essentially, look what we have now. We have our original given line with 2 points on it. And we have now, with our construction, created 2 more points, or rather, P was already given, but we have created point R. And now we're going to connect these 2 points with a line, and that line is going to be parallel to our originally given line. Neat, isn't it? Here we go, and we go ahead and draw our new line going through P and R, and this line is parallel to the original line. Okay, this is actually maybe the most complicated of all the constructions that we have seen or will see. All the other ones are part of this in some way. So if you get this down, then you're going to be good with constructions. We're going to review one more in one of the next classes, but I'm pretty sure that this is the construction with the most steps. And again, of course, we're going to practice this in class some more. All right, now for your summary, I want you to explain the difference between the slope of lines that are parallel and perpendicular and lines that are neither of those two things. Just think about what we said about their slopes. Explain the difference between the slopes for lines that are parallel, perpendicular, and neither. Have fun, and I will see you in class.